You will need the following instruments to implant a MAGNEZIX compression screw 3.2, a guide wire, the measuring device, the cannulated drill bit, the cannulated countersink, a small insert drill sleeve, a double drill guide, and the screwdriver. To determine the length of the screw, slide the measuring device over the inserted guide wire to the bone. The end of the guide wire, visible in the scale of the measuring device, indicates the length of the screw. Position the guide wire through the double drill guide with the drill guide attached. Make sure you use the correct color-coded tools here. The drill guide must be removed before you drill the pilot hole to the desired screw length using the cannulated drill bit directed by the underlying guide wire. To make it easier to insert the screw head, use the countersink to enlarge and bevel the point at which the head of the screw will sit flush with the bone surface, meanwhile making sure that the guide wire is still in place as you do this. Make sure you use the correct color-coded tools here. If the screw is being positioned perpendicularly to the bone surface, you only need to countersink to the first ring marking. If the screw is positioned obliquely to the bone surface, countersink to the second ring marking to ensure the screw head lies flush with the bone. Screwdrivers are available with a one-piece or multi-part handle. To assemble the screwdriver, insert the screwdriver blade into the one-piece or multi-part handle. Press the cap at the end of the handle to secure the screwdriver. This video describes the treatment of a distal fibula fracture using a MAGNEZIX compression screw 3.2. Before the MAGNEZIX 3.2 compression screw can be inserted, the fracture must be repositioned and temporarily stabilized. Position the guide wire through the double drill guide with the fitted drill guide until it is in the required position. If necessary, monitor using an image intensifier. Avoid using excess force when inserting the guide wire. This will bend the guide wire and make it difficult or impossible to ream or insert the screw later on. Use the associated measuring device to determine the length of the CS 3.2 compression screw. In our case, the length is 40 millimeters. At least 2 millimeters must be subtracted from the measured length to ensure that the guide wire does not detach from the bone during the subsequent pre-drilling process. In this case, we will therefore use a CS 3.2 with a length of 38 millimeters. The hole is drilled over the guide wire to a depth of 38 millimeters. The calibration of the drill bit makes it easier to read the drilling depth. Each of the fine rings represents a depth of 2 millimeters. Each of the deeper rings represents a depth of 10 millimeters. Once you have finished pre-drilling, leave the drill bit turning slowly in a forward direction and pull it out vertically from the drill guide to ensure that the guide wire remains in position. To make it easier to insert the screw head, use the countersink to enlarge and bevel the point at which the head of the screw will sit flush with the bone surface, meanwhile making sure that the guide wire is still in place as you do this. If the screw is perpendicular to the bone surface, the head space only has to be enlarged to the first ring mark to ensure the screw head can be completely countersunk. If the screw is not perpendicular to the bone surface, the head space must be enlarged to the second ring mark to ensure the screw head can be completely countersunk. The 38mm MAGNEZIX CS 3.2 screw can now be inserted over the guide wire. Make sure that the guide wire has not been damaged in the previous steps. If the guide wire has been damaged, it may not be possible to fully tighten the screw. In this case, the guide wire must be removed before the screw has been completely inserted. If too much compression is generated while the screw is being tightened, this could pull out the screw thread in the far fracture fragment. If the screw is too short, the shaft thread might cross the fracture or osteotomy gap. In this case, no compression will be generated. We therefore recommend using an image intensifier to check that the shaft thread is positioned correctly. When you start tightening the head, you can now see the compression being exerted on the fracture gap. Before finalizing the insertion procedure, remove the repositioning aid to check how much compression is exerted on the fracture gap. After this, remove the guide wire. The fracture has now been treated.